We have been discussing what is often called multi-step problems in algebra. And that's when algebra starts to get a little complicated. So I've made sure that we had enough room in the schedule to make sure we spend a couple of days on it. So what I'm going to do is get my notes here, and then we will get rolling. Most of today is not going to cover any new material, but we are going to I'm going to work out several problems for you just so that you kind of have that um, in your. Where did you go? There you are. All right, so the first one's going to be negative 169 is equal to negative 4 times the quantity 8x minus 4 plus 7. Okay, and all right, we've got some more people on. All right, so Kathy's iPhone. What student, if you just want to message me directly your name, just so I'm taking roll, um, we have that. All right, so here, remember that one of the things that we can keep in mind is we are going to utilize the um, order of operations, right? So we want to look inside this parentheses first. And what we can see is that we have the 8x minus 4. However, I can't just combine those two because they're not, as we talked about last week, like terms. I cannot add or subtract terms that are not like. In order for me to do that, they would have to have the same variable. Okay. 4 does not have an x like 8 does. They would also have to have the same exponent. In this case, it doesn't matter because it doesn't even have an x on the 4. So we can't combine those two. So what do we do? Well, there's a couple of things that we could actually do. We are adding a 7, so we could actually subtract that 7, and we could subtract 7 on both sides. The other thing that we can do is we can distribute. We can distribute the negative 4, I should say, into the problem. Either one of those are acceptable. So if we look over here at PEMDAS, usually we want to be multiplying first if we don't have any parentheses and we don't have any exponents. And so why don't we go ahead and do that? So negative 4 times 8, negative 48x. Then negative 4 times negative 4 is positive 16 plus 7. So go ahead and take notes. And what I would do when you guys take notes, there's a couple of things in algebra to keep in mind. Make sure that you take notes vertically, meaning that every line, every time you work an operation, you'll see me do this on my paper. It's a new line for every operation that we do. So here, do you see how I multiplied the 4 through? Boom, new line. Don't just write what's here, bring down that positive 7, bring down that negative 169. Keep everything neat. Then line up your equal signs. Okay. Keep those equal signs lined up all the way down. There's nothing magical about that. It's not that math is incorrect or correct based on doing that. It's just really good practice. It will make your life a lot easier, especially as these problems get a little more complicated. All right. So I can combine the 16 and the 7 together. So without even subtracting anything to the other side, I've already got something that I can combine there. So all you have to do is add that 16 to the 7. So I'm put my equal sign there, my negative 169 here, negative 48x, and then 16 plus 7 is 23. All right, now this looks a little bit more manageable. Okay, I've got a negative 169 equal to negative 48 plus 23. I'm sorry, that should be 32. What am I doing? Negative 4 times 8 is negative 32. I can't believe none of you caught that. That's funny. All right. So that should be negative 32. Okay. Now I am going to subtract 23 from both sides. Because remember, I can add, I can subtract, I can multiply, I can divide anything I want from those two sides. So if I subtract 23 from 169, be very careful here, because it would be easy to miss the fact that that's a negative sign there and simply subtract 23 from positive 169. I see a lot of students that. I'll look over here and I'll see a 146 because they just subtracted off the 23. But in fact, that's negative 169, and I'm subtracting an additional 23. So that's going to be negative 192. Okay. All right. So I've subtracted the 23 from both sides. Now I'm left with negative 192 is equal to negative 32 times x. Now here, I can divide both sides by negative 32. Okay. All right. And, well, what is that? Since it's a negative divided by a negative, I know it's going to be a positive, so I'm not going to worry about what that's going to be. So 32 can't go into 19, 32 into 192. Now I got to count by 32s. Let's see here. We'll go in evenly 2, 4, 6. Yeah. Okay, yeah, that is 6. Cool. So 6 is equal to x. All right, 6 times negative 32 is negative 192. All right, get that in your notes. Make sure your equal signs are lined up. Make sure all the adding and subtracting is very clear, that you're subtracting here in this case, negative 23 from both sides. I'm dividing. There you go. Okay, now what I'm going to do, we're going to work the same exact problem, except we're going to do it a different way. Okay. What happens if we subtract that 7 from both sides? Okay. All right. So 169, then subtract 7, that's going to be negative 176 is equal to negative 4, 8x minus 4. Okay. Make sure everybody's got that on their paper. Give you a minute to write that down. All right. Now, notice here that I can go ahead and multiply this 4 in if I want to. But the other thing that I can do, since I have negative 4 times a quantity, which is one entire number, two things being multiplied. Since I have parentheses here, it's this times this, okay? So what I can actually do with two numbers is I can divide out one of those numbers, okay? I can divide out the negative 4s. Negative 4 over negative 4, that's going to cancel because negative 4 over negative 4 is 1. 1 times the rectangle is just the rectangle. So all I have is the rectangle is equal to negative 176 divided by negative 4. That's going to end up being positive 176. 4 goes into 17 4 times. It's 16. 4. All right. So that's going to be 44 is equal to the rectangle. And what's the rectangle? 8x minus 4. I don't need the parentheses now that I'm only left with the rectangle. I'm only left with the quantity. All right. So then here, I can add 4 to both sides because I can add and subtract, multiply, and divide anything I want on both sides of the equation. In fact, that's our justification up here. Well, why didn't we do multiplication first if that's what order of operations tells us? That's because, according to one of the axioms that we studied last week, it is legal, even if it's not in the right order, to add or subtract, multiply or divide anything you want on both sides of the equation. So that's kind of what we're leveraging here. And that's going to be very powerful to finding our answer. Okay, so if I subtract 4 from this side here at 8x minus 4, it gets rid of the 4's, and I'm left with 8x. If I subtract, I'm sorry, I'm not subtracting, I'm adding, because I already have subtraction. It's already 8x minus 4, so I'm adding 4. That leaves me with 8x. And then I'm going to add 4 here. 44 plus 4 is simply 48. Then if I divide both sides by 8, 48 divided by 8 is 6. X is equal to 6, which is what we found out before. All right. Any questions so far? All right, keep your notes alive. We're going to work the same problem again, but we're going to do it differently. And I'm doing this on purpose because what I want to show you is it doesn't matter which way we go about solving it. As long as you perform legal math, you can do this however you want. Okay? So, the first time we multiplied through by this, the next time we subtracted 7 on both sides, and then we divided out the 4. You can subtract 7 first and then multiply this through. That's really not going to change much. There's really not a more fundamental way. You could divide both sides by 4, and this is what I see a lot of students do. This is going to cause more work, but it is legal. Now, what I see a lot of students do is their very next problem, they say, oh, we've eliminated the 4 here, so I'm just left with 8x minus 4 plus 7. That is incorrect. Notice this plus sign here, okay? Notice that this negative 4 is only being multiplied by this quantity. It is not being multiplied by this plus 7. So when I divide this whole thing by negative 4, that's the same thing as splitting this up. Okay? Just like when we get a common denominator. So let me do that real quick. When we have a simple fraction like 1/3 plus 1/2, right? We need a common denominator. So I'm going to multiply the top and the bottom here by 2 because I'm multiplying it by 1, and it's still the same thing, just expressed differently. So this is 2 over 6 here. This is 3 over 6. So when I add this, I don't add the bottom. That just stays the same. I just add the top, right? Well, that's the same thing as if you had this. 2 plus 3 over 6. 2 plus 3 over 6 is 2 over 6 plus 3 over 6. It's not just 2 over 6 and then plus 3. It goes with both. So we're doing the same thing here. Across this plus sign, not this minus sign, because remember, this is a number we're multiplying. It's a quantity. Quantity times negative 4. That has its denominator of negative 4. But here we're plus 7. So that you're going to split that denominator, and it's going to go under each of the terms. This is one term here. This is term number 2 there. Okay, that's a little hard to see because we have parentheses in here and we have a subtraction. Your temptation is to think, oh, so the negative 4 goes under this and then under the 4 and then under the 7. No, this quantity is this first, then we multiply that by the negative 4. So the negative 4 in the denominator only is dividing this quantity here, okay? All right, so then that gives me negative 169 over negative 4. And you can already see that, wow, this looks confusing now. Because now I'm going to add 7 over negative, or, yeah, 7 over 4 to both sides. Okay, so then I'm left with this negative over negative is positive. So I have 169 over 4 plus 7 over 4 is equal to, the negative and the negative here cancel. So that's 4 times 8x minus 4 divided by 4. Okay. 169 plus 7 is 174. Write down what we got so far. 169 over 4 plus 7 over 4 is equal to 4 times 8x minus 4 over 4. And we already, the 7 over negative 4 got added over here. Okay, so this is now 174 over 4, which is equal to 4 times 8x minus 4 over 4. Okay, so you can see that we've gone several steps already, and we haven't even gotten close to getting to the right answer, or to the final answer. So introducing this fraction early, eventually, if I kept working this, we would get to the right answer. I think for time's sake, I don't want to do that, but you kind of see the point I'm making. Introducing fractions early in these multi-step equations is not necessarily the way to go. All right, so why don't we do this? Let's do another one. Negative 120 is equal to negative 8 times 1 minus 7p. All right. So the first thing I'm going to do is I'm going to multiply that negative 8 through. I'm going to distribute. So I have negative 120 is equal to negative 8 times 1, negative 8 times negative 7. All right, then I'm going to add 8 to both sides. Keep those equal signs lined up. This negative 8 and positive 8 cancels. I'm left with 56 times p, and the negative 120 plus the 8. Now be careful there, because your tendency is to subtract another 8, or your tendency is to get the sign wrong. So remember, we're in the whole 120, and we're going to come up 8. So that we're going to be at negative 112. Okay. Then we're going to divide by 56. We're going to divide by 56. So if I divide 56 here, those cancel. I'm left with p. And 112 divided by 56 is 2. And I have a negative divided by a positive. So I have negative 2. So you can see we got here in 1 step and 2 steps. You know, we could say 3 is the final answer. Making sure that we keep everything nice and together. All right, let's do another one. All right, let's do one a little bit more complicated. Let's do negative 3 times 4x minus 2 is equal to negative 7x plus 7. All right. So the first thing I'm going to do here, there's nothing I can add or subtract on both sides because I am multiplying this rectangle times a number, and then I'm multiplying this rectangle here times that number. And notice those two rectangles aren't the same. So, but what I can do is I can multiply this -3 in, and then that'll allow me to drop those parentheses. -3 times 4 is -12x. -3 times -2 is +6. I'm going to do the same thing here on this side. -7 times x, -7x. -7 times +7 is -49. All right, now I've got things that I'm adding and subtracting. And notice that I have some like terms. Okay, so it doesn't matter if I take this and move it over here, or if I take this and move it over here. I'm going to bring the 12 over. So I'm going to add 12x, -12x plus 12x cancels, and you're left with 6. -7 plus 12x is +5x. Now, one quick thing I want to point out here, just so that we're writing out everything correctly. So you see how the, the equal signs are lined up, but notice how there's no equal sign here between this, the +12 and the +12. Okay. The reason is because I'm adding this to this and I'm adding this to this. I'm not setting this equal to this. Okay. So more formally, and we don't have to do this, but more formally, you would add it over here, +12x, and over here, +12x, or just 12x. Okay, so 12x minus 12x, that goes away. You're left with 6. Then here, -7x minus 49 plus 12x, you're left with 5x. So that's more formally what we're doing. I leave it down here because I think it's a little bit easier to see, but don't make the mistake of putting an equal sign here between the, even though they are equal to each other, that's not what's going on. The 12x is being added to this line on this equal sign. And this 12x is added to this line on this equal sign. Okay? So just keep that in mind. All right, I'm going to add 49 here to both sides. This is going to be 55 is equal to 5x. I'm going to divide both sides by 5. 5x divided by 5 leaves me with x. 55 divided by 5 leaves me with 11. Okay, so this was my first step here. This was my second step here. Then I simplified down to the 11 equals x. Make sure you put a question mark through if any of this does not make sense. And we will move on to another one. All right, let's do 5 times 3p minus 5 plus 3 times -2r minus 7 is equal to 4 plus 4r plus 5r minus, I'm sorry, p. What am I doing? -2p there. 4 plus 4p plus 5p minus 6. We're not getting into multiple variables in our equations yet. Okay. So here I can see that I have like terms, my 4p and my 5p. I can combine those two. So let's go ahead and do that. 4p plus 5p is going to be 9p. Okay. The other thing you're seeing me do here, the temptation is going to be that you do more than one operation per line. And as you get better and better with this, you can start doing that. But for right now, keep it one operation per line. I would highly recommend that you do that. It does take more time, but it also eliminates a lot of mistakes. Most of the time when a student comes to me and we're going over their work, we go back to doing it line by line. Almost always they catch their mistake. I usually don't have to point it out to them because they see it pop up when we go line by line. All right. So here we have positive 4 and negative 6. I can combine those two to be negative 2. 9p minus 2. Now, when we're doing the same operation within one line, so for example, 5, you're going to distribute here, then yeah, I think it does make sense to go ahead and distribute that 3 there. Just because we're kind of thinking about the same thing and there's very little overlap between these two. So I don't see you necessarily getting confused. We're not doing it on both sides of the equation, trying to keep this, and then all of this factoring in or distributing straight. So with that being said, let's go ahead and distribute this 5 into this quantity. 5 times 3, p is 15p. 5 times negative 5 is negative 25. Then here we have 3 times negative 2. That's negative 6p. 3 times negative 7. That's negative 21. All right. I've got like terms, so I'm going to combine the 15p with the negative 6p. And that's going to give me 9p. And then I've got minus 25 minus 21. All right. Negative 25 minus, oops, let me add this to the side. Negative 25 minus 21, that's going to be negative 46. We have 9p minus 46 is equal to 9p minus 2. I'm going to add 2 to both sides. 9p. And then if I add 2 to negative 46, that's negative 44 is equal to 9p. Then if I subtract 9p from both sides, something very interesting happens. Okay. 9p goes away on the left and 9p goes away on the right. And what I'm left with is negative 44 is equal to 0. Does anybody see a problem with that? And everyone should, because negative 44 is not equal to 0. But I just worked out the problem and it says that it's equal to, oops, sorry. It says that it's equal to 0. When this happens, this means that there is no solution. Okay? There is no solution. And what that means is there is nothing that I can plug in for P that will make this come out right. Because no matter what number I plug in for P, let's say 2, this becomes 18, this becomes 18, you're still going to end up with negative 44 is equal to 0. Some number not equal to another number. That is impossible. So that means that what we're left with is no solution. And that can be an answer on the problems that you guys are working. There can be a situation where there is no solution. All right. Let's do another one. Let's do 2 times the quantity, 7x plus 7, minus 3 times x plus 2 is equal to x plus 3 minus 5. All right, so what I want everybody to do is write this out. I'm not going to say anything. I'm just going to go line by line by line. So if you're not comfortable yet, go ahead and just copy down what I'm doing. If you do feel kind of comfortable, see if you can go line by line and get to the answer before I do. Okay? So we'll kind of race here. I'll go slow on purpose so that we don't you don't feel too overwhelmed. Right. All right, a couple of you messaged in. Good job. A couple of you got it right. Some of you not so much. And that's okay. Make sure you copy down what I got here. X is equal to -1. X is equal to -1. Okay, we're developing an algebra skill right now. So we talked a lot about in the first couple of weeks, or in the last couple of weeks, this is week 4, but we've talked a little bit about how the equation balances, how there's different things on both sides of the equation, how we can add, subtract, multiply, and divide. And now we're just manipulating these equations. We're getting used to manipulating these equations so that we can solve more complex problems. Okay? All right. Let's do another one. 7m minus 8 times the quantity m plus 2 is equal to 6 times m minus 5. All right, and I'll kind of do the same thing here. I'll kind of just go through and work it line by line. You can copy what I'm doing, or you can work it yourself and see if you can get to the final answer before I do. All right. All right, I'll give you guys a moment to copy that down. M is equal to 2. Still haven't found the type of question that I want to do here. That's okay. All right. Let's do another one. All right. Same deal. Work it on your own. Follow along either way. All right. Good job. We got several people that had done that one. A couple of people put -8. It is not -8. Be careful with those negatives. It's one of the common mistakes. -5 times 5 is -25. -5 times -4 is +20. We're adding 25 to both sides. -185 plus 25 is, oh, wait. No, that is correct. I'm sorry. I'm the one that messed up. Look at that. I am the one that messed up. That should be -8. Double check the answer in my notes here just to make sure I didn't do something wrong. Yep, -8. Good job. I got that wrong. That's how easy it is to. That is how easy it is to mess these up. Good work. All right. I said my students do it. Here I am doing it. All right. Do some more of. Right. 7 times the quantity of x minus 6 is equal to -6 times the quantity -5x plus 7. Make sure you're taking notes, especially if this is kind of struggling for you, because you want to make sure you have a lot of examples. Sometimes okay. I need to be doing my times tables. X is equal to 0. Several of you got that. Way to go. Do one more. All right. I'm going to actually do this in a different color. You can see the answer here, but I'm going to go ahead and do it all the way. N is 1.